Okay, let's look at another type of integral using some trigonometric identities. And this one is where we have a sine times a cosine, or a sine times sine, or a sine times cosine, but they have different arguments. And we can use these product to sum identities to help us out. So sine of u times sine of v is 1/2 parentheses cosine of u minus v minus cosine of u plus v. Cosine u times cosine v is 1/2 cosine u minus v times cosine of u plus v. Sine of u times cosine of v is 1/2 sine u minus v plus sine of u plus v. And so if you have an integral of something like something on the left, we just use it, switch it to the integral on the right, then it works out pretty easily. We'll do an example of using each of the three here. So if you integrate sine of 3x times sine of 2x dx, then we use this identity. Let's see, it's the first one. So it's 1/2, which I can bring out in front of the integral sign, cosine of the 3x, then minus the 2x, minus cosine of the 3x plus the 2x. Well, 3x plus 2x is 5x. 3x minus 2x is x. And we're going to break it into two integrals. I just left the 1/2 here. The antiderivative for cosine x is sine of x. And if we put a 5 here and a 1/5 out with the 1/2 and the minus, makes minus 1/10. We have cosine of u du, so that's the antiderivative is sine of u. So that's a sine of 5x times the minus 1/10. Don't forget your plus c. And so the antiderivative we're looking for is 1/2 sine of x minus 1/10 sine of 5x plus c for that family of antiderivatives. The next one, we're going to use the middle identity, cosine of 5x times cosine of 4x dx, and we're going to integrate that. Again, it's a 1/2, but we have cosine u minus v plus cosine of u plus v. So you subtract them here, add them here for the arguments, and it's adding in the middle, right? Yeah, adding in the middle. And so 5x minus 4x again is x, 5x plus 4x is 9x. This one is 1/2, the integral of the first one. I'm going to put a 9 here, 1/9 with the 1/2 here, makes a 1/18 here. Antiderivative of cosine x is sine x. This is cosine u du, where u is 9x, du is 9 dx. So the antiderivative is the sine of u, sine of 9x. So the antiderivative, or family of antiderivatives, is 1/2 sine of x plus 1/18 sine of 9x plus c. And similarly, we're going to use this last one here when we have a product of a sine and a cosine, different arguments, see, different inputs. We're going to get sine plus sine here, where this is a difference and a minus. And so difference in a sum with a plus in the middle. So the integral of sine of 5x cosine of 2x dx is 1/2. I bring out in front of the integral. Sine of 5x minus 2x plus sine of 5x plus 2x. 5x minus 2x is 3x. 5x plus 2x is, 5x plus 2x is 7x. Let's see if we can fix that. That is 7x. So this would be 7 dx. This would be 1/7 times the 2 is 1/9. No, 1/14 because you're multiplying them. 1/7 times 1/2 is 1/14. Okay, so that's good. The antiderivatives, this is sine u du. I took the 3 here, put the 1/3 with the 1/2 to make a 1/6. The antiderivative of sine u du is cosine of u. The u is 3x. The du is 3 dx. It's actually minus that. So we have a minus there. Similarly here, but this should be a 14, and this should be a 7. There we go. And we have that one now worked out correctly. I'll leave the checks to you to make sure everything was done right. So at this point, we've kind of finished this little section. This is basically section 8.3 in the Larson and Edwards calculus textbook, the early transcendental version of it. And it's time to do some homework problems and put these different techniques to work for you. First of all, study that section in your book. You'll see some more examples to complement the ones that I have here. And with those examples of the book and the ones that you have here in my videos and my notes, you should have plenty of examples to get a feel for what's going on. But of course, you don't never learn how to do things until you actually try them yourself. So you need to find some problems and work them. For my students, it's time to get homework set 1.2 for my Calculus 2 class and work the first 23 problems. And I will say this, many of these problems are very straightforward integration problems. They follow the models that I have here very closely. But a few of them may be more challenging. Sometimes you just have to dive in and try something. Just try something and see where it leads. If it leads to a dead end, okay, that's fine. That didn't work. Try something else. And it takes a little perseverance to get through with these. If you do get stuck, then be sure to ask your instructor a question. So for my students, I don't mind giving out hints, but I really would like you to make a real effort first before you try to ask me questions. But if you still have questions, be sure you use the Ask Instructor link in the homework and ask questions that way, or email me questions when we have our sessions. If we have some where we're in person or Zoom sessions or something, you can ask questions there. You can come to my office hours, that sort of thing, to ask questions. So in any event, just keep working at this stuff. Give it a try. It takes a little perseverance, a little practice to get good at this stuff. But hopefully you'll get better and better at this as we go. All right, do some homework. Come back then. Our next videos will be about another technique called trigonometric substitution.